What's inside the moon, that celestial body that has been a source of fascination for centuries? Our silvery companion in the sky has always been a part of our lives, influencing our tides, lighting up our night skies, and even guiding our calendars. But despite its constant presence, the moon holds many secrets, especially about its interior. What lies beneath that rocky exterior? Is it hollow or packed with dense material? Stick around to unravel the secrets that lie beneath the moon's surface. First, we'll delve into the moon's crust, the outermost layer that we see with our naked eyes. Picture a world with a crust so different from ours, yet so familiar. That's the moon's crust for you. This fascinating outer layer is the moon's hard shell, and it's the first thing that comes into contact with the space environment, protecting the inner layers from the harsh realities of space. The moon's crust isn't uniform. It's about 30 miles thick on the side facing us, but it can be as much as 60 miles thick on the far side. That's quite a variation, right? And just like a good mystery novel, there's a twist. This crust doesn't spread evenly across the moon's surface. Instead, it's lumpy with highlands and basins, mountains and valleys. So what's the moon's crust made of? Here's where we get a little bit technical. The primary elements are oxygen, silicon, magnesium, iron, calcium, and aluminium. But the most abundant mineral in the crust is plagioclase feldspar, which gives the moon its signature grayish-white appearance. Now, how does the moon's crust differ from Earth's? One of the most striking differences is the absence of plate tectonics on the moon. Here on Earth, our crust is divided into several large plates that float around on the semi-fluid layer underneath. These plates are constantly moving, colliding, and diverging, causing earthquakes, volcanoes, and even the creation of new land masses. But on the moon, the crust is a single, solid piece. There are no tectonic plates to cause moonquakes or create lunar mountains. Another key difference is the presence of a unique feature on the moon's crust called regolith. This is a layer of loose, fragmented material that covers solid bedrock. It's made up of dust, soil, broken rock, and other related materials. The regolith is the result of billions of years of meteoric impacts, and it gives the moon's surface its powdery texture. Now that we have an understanding of the moon's crust, let's go deeper. Moving deeper, we encounter the moon's mantle, a layer that tells a story of the moon's violent past. This region, extending from the crust to the core, is a testament to the celestial body's turbulent history. The mantle, which makes up a substantial portion of the moon, is primarily composed of minerals such as olivine and pyroxene. These are common in the Earth's mantle too, underscoring the shared history of our planet and its constant companion. But the moon's mantle isn't a simple copy of Earth's. It's a unique tapestry of elements that narrates an intriguing tale of cosmic forces at work. The story begins with a catastrophic event. Around 4.5 billion years ago, a Mars-sized body, often referred to as Theia, collided with the young Earth, ejecting a considerable amount of debris into space. This material eventually coalesced to form the moon. The heat from this impact partially melted the moon, creating a magma ocean. As this ocean cooled and solidified, the moon's crust and mantle were formed. The denser materials sank, forming the mantle, while the lighter ones floated up to create the crust. The moon's mantle reveals a violent past, but it also hints at a surprisingly dynamic present. Recent studies suggest that the moon is not entirely cold and dead, as once thought. There could be pockets of molten rock or magma beneath the surface, remnants of the moon's fiery birth. These pockets could be responsible for the moonquakes we've detected, shaking the lunar surface from the inside. Understanding the lunar mantle is not just about uncovering the moon's past. It's also about looking forward to the future of lunar exploration. The mantle's resources, such as helium-3, could potentially be used as a source of clean energy back on Earth or to sustain a future lunar colony. With the mantle explored, we now venture into the moon's core, a region shrouded in mystery. It's time to delve even deeper into the heart of our celestial neighbor. Let's keep exploring, shall we? Finally, we reach the core, the moon's innermost layer, believed to be small and partially molten. The lunar core, much like a well-kept secret, is shrouded in mystery. Its exact size and composition are still subjects of intense debate among scientists. Current estimates suggest that the lunar core comprises a mere 1 to 2% of the moon's total mass. To give you a mental picture, if the moon were the size of an orange, its core would be no bigger than a cherry pit. Now, what makes up this tiny core? Primarily, it's thought to consist of iron with smaller amounts of sulfur and nickel. These elements are believed to be remnants from the moon's fiery birth over 4.5 billion years ago. The presence of these heavy elements in the core is what gives the moon its slight gravitational pull. The core is also thought to be partially molten or liquid, unlike the completely solid core of the Earth. This difference has significant implications. For instance, Earth's solid core, rotating within a liquid outer core, generates a magnetic field that protects us from harmful solar radiation. The moon, with its partially molten core, lacks such a magnetic shield. Comparing the moon's core to Earth's, we see stark contrasts. Earth's core is much larger, comprising about 1/3 of our planet's total mass, and is mostly iron. It's also divided into two parts: a liquid outer core, which creates the magnetic field, and a solid inner core. The moon's core, on the other hand, is much smaller, lighter, and simpler. It's a testament to the moon's less dramatic geological history and smaller size. Despite these differences, studying the moon's core provides valuable insights into not only lunar history, but also the broader processes of planetary formation and evolution. Having journeyed through the moon's layers, we now have a better understanding of what lies beneath its surface. So what have we learned about the moon's interior? Well, we've discovered that it's a lot more than just a big gray ball in the sky. The moon has a layered structure, just like Earth, composed of a crust, mantle, and core. But each of these layers is unique, with its own set of fascinating features and properties. Let's start with the crust. The moon's crust is its outermost layer, a protective shell of sorts. It's composed primarily of oxygen, silicon, magnesium, iron, calcium, and aluminum, with traces of other minerals. This crust is much thicker than Earth's, averaging about 43 miles in depth, and it's marked by an abundance of craters and basins caused by meteor impacts. Beneath the crust, we find the mantle. This layer is predominantly made up of minerals like olivine and pyroxene, which are also found in the Earth's mantle. The moon's mantle extends to a depth of about 700 miles. The moon's interior gives us a deeper understanding of our closest celestial neighbor. It helps us understand its history, its geologic activity, and its potential for future exploration. The moon is not just a pretty face in our night sky, it's a complex and dynamic world with a lot to offer. Next time you gaze up at the moon, remember the complex and fascinating structure that lies beneath its surface. The moon, our closest celestial neighbor, continues to fascinate us with its mysteries. As we delve deeper into understanding our lunar companion, its secrets help shape our knowledge of the cosmos. The ongoing exploration of its interior adds another layer to the rich tapestry of scientific discovery.